All right, so when you're doing arithmetic, the one thing that we really need to remember is that division behaves differently based on whether it's floating point numbers or integer numbers. If we do this, if we say x is equal to 1 over 2, you'd think that that would equal 0.5, but it doesn't. This is an integer. This is an integer. An int divided by an int results in an int. So whatever you get there will be rounded down to the nearest whole number. So 1 over 2, well, 1 over 2 is 0.5. Rounded down to the nearest whole number, x is going to equal 0. Even though it doesn't look like it. Even if this says double, right? Even if it's got some kind of super precise data type over here, it doesn't matter. This calculated out to 0. And so 0 is going to get copied across the equal sign and stored into x because it's doing integer division. If both operands of division are ints, the result is an int. And that can bite you. Like if the equation is 4/3 times x, right? Y is equal to 4 divided by 3 times x. If they're all integers, then 4 and 3, what's 4 divided by 3 rounded down? That's just 1. Not going to give you the answer you want, right? Not going to do what you want. So this would not be a good idea because 4 divided by 3 equals 1, counterintuitively. Instead, you'd want to do y is equal to 4.0 divided by 3.0 times x, something like that. Because 4.0 divided by 3.0 equals what you want it to. That's different from Python. So you folks who walked in here from Python would just need to remember that in that language it didn't matter whether you were dividing integers, long numbers, in floats or ints. In this one it does. Division behaves differently based on whether the both operands are ints or not. Now honestly, you don't have to convert both of these to a float in order to get it to work. You could just turn one of them like that, and it'll still equal 1.333. The only trouble is when you get to here, 4 divided by 3. So when the Java virtual machine performs division on floating point numbers, it does so-called calculator division. I don't know why we've got to give it the name calculator division. It's floating point math because Java's floating point division works the same way as division working on a calculator. If you divide 9.0 by 4.0 on a calculator, you get 2.25. But if you divide 9 by 4, you're just going to get 2. So this would print out 2.5 or 2.25 because these are floating point numbers. But if we remove those and ran it, it would just print 2 because they're both integers. So 9 divided by 4 rounded down is 2. So two ways to perform division on integers. You can do divide or you can do the percent sign. I don't think of that as two ways of doing division. But this gives you the quotient and this gives you the remainder. 9 divided by 2, 2 goes into 9 4 times. 9 modulus 2, 2 goes into 9 4 times with a remainder of 1. 15 goes into 5 how many times? 5 divided by 15? Well, 15 can't go into 5. So 15 goes into 5 0 times with a remainder of 5. So if we have 2 divided by 3, that's 0. 2 modulus 3, Well, 3 went into 2 times. Excuse me, 3 went into 2 0 times with a remainder of 2. 3 divided by 3. What's 3 divided by 3? 1. So 3 modulus 3. When you divided 3 into 3 one time, what was the remainder? Does 3 divided by 3 give you any remainder? No. It's a remainder of 0. That's what modulus means. Modulus means remainder. So percent sign means modulus, means remainder. So 10 modulus 7, well, 10 divided by 7, how many times does 7 go into 10? They're both integers, so there's not going to be any decimal points, so 10 divided by 7 rounded down is what? 1, right? And then 7 goes into 10 one time with a remainder of 3. Yep. So the percent sign also performs grade school division. Why did they say that? Anyways, it's integer division. So given these initializations, use Chapter 3's operator precedence table. Well, I'm not looking at the operator precedence table, but I do remember PEMDAS, which means that parentheses have the highest precedence, and then multiplication and division, and then finally addition and subtraction. So let's figure out what this is going to equal. What's the first thing that's going to happen here? The stuff inside the parentheses. What's the first thing that's going to happen inside the parentheses? The division. So x is 10, y is 4. They are both integers, so 10 divided by 4 rounded down is what?
2.
2, okay. Now we're ready to do the rest of this. This is 6.0. So 6.0 plus 2 is 8.0. You can get rid of that, and then we can just run from left to right. 8.0 divided by 10 is 0.8 times 2 is 1.6. Something like that, right? Now for the next one. 0 modulus x. Well, that's silly because 0 modulus anything is equal to that number, right? Because 10 can't go into 0. 20 can't go into 0. So this 0 modulus x is equal to 10. I'm sorry that they did that because it's stupid. If you had this, 0 goes into 10. Is that what it means, or does it mean 10 goes into 0 0 times with a remainder of, what's hurting my brain? Isn't it just 0? If you don't have any value there, how could you have a remainder? So that's 0. 0 plus z plus 0 divided by x. Well, 0 divided by x, x divided by 10 is, since these are integers, 0 divided by 10, well, it's still 0. So it's 0 plus z plus 0. That was a really stupid problem. I don't like that one. Let's come up with a couple better ones. Pardon me?
Why would you be putting that in a program anyway?
Right, I'm not approving of that one. Let's come up with our own. Load up Notepad or Word or whatever you like taking your notes into, and let's say that A is equal to 3, B is equal to 4, and I want you to tell me the answer to these results. A plus B times 2, A times B plus 2, A modulus B plus 2, and B modulus A minus 2. So just kind of work them out. Then we'll do them together. But the top one. What is that? Just blurt out the answer.
14.
Yeah. So, what is b times 2? That's 8. Plus 3 more is 11. Is that what everybody got?
Mm-hmm. No,
I think you said 13. How come?
I did my order of operations wrong.
Oh, okay, okay. Yeah, order of operations. This one is what you just
14.
said. All right, yeah, so that'll be 14 because 3 times 4 is 12 plus 2 more is 14. How about this one? What is 3 modulus 4? 4 goes into 3 0 times with a remainder of?
1, 4.
I haven't heard any right answers yet.
I had them. I had them. Okay, is it 5?
All right, so if we have 3 here, and we're dividing 4 into it, 4 goes into 3 0 times with a remainder of?
4.
3, right? Because the whole thing was left over.
And
Yeah, because if you have 4 mod 4, that's a 0. 5 mod 4, that's a 1. 6 mod 4, that's a 2. 7 mod 4 is 3. 8 mod 4 is back to 0. And here we had 3 mod 4. So 3 mod 4, 4 goes into 3 0 times with a remainder of 3. And 2 modulus 4, what would that have been? 4 goes into 2 0 times with a remainder of? 2. All right, so 3 modulus 4, we decided was 3. Plus 2 is 5. What about the next one? What is 4 modulus 3? Four goes into 3 how many times? 1. With a remainder of? 1. I hope we're all good on that. If we have 4 here, and we have 3 there. I know we don't do long division anymore, but 3 goes into 4 one time with the remainder of 1. That's the modulus. So 4 modulus 3 was 1 minus 2. I guess is going to be negative 1. And if we'd use parentheses in any of those, I know you know how to do parentheses. But if I'd like put parentheses there, you would know how to do that. You would just do that part first. So given these initializations, wait, we just did that one. So increment and decrement. X plus plus is the same thing as writing x equals x plus 1. X minus minus is the same thing as saying x equals x minus 1. It's good programming style. It's proper style to go ahead and say x plus plus and x minus minus rather than x equals x plus 1 or x equals x minus 1. However, there are some subtleties that that slide does not mention. I assume they get to it. If you have this, x plus plus, that's the same as x equals x plus 1. So is this. That's also the same as x equals x plus 1. The difference is that if you have the plus plus in front of the letter, if it's a prefix, it means it's the very first thing that happens in the expression before anything else. And if you have it after the letter, it means it's the very last thing that happens in the expression before anything else. We haven't done any code yet, so let's go ahead and update is in progress. I am not happy to see that. Please don't. All right, so what we're going to do is we're going to create a variable. We'll have two variables, x and y. We're going to set x equal to 5, and then we're going to say y is equal to plus x. And then we're going to print out the values of x and y. System.out.println, parentheses, quote, x equals, end quote, plus x, in parentheses, semicolon. System.out. Do the same thing for y. So when we run this, it's going to say that they're both equal to 6. What is this statement right here doing? Plus x means add 1 to x, store it back into x, and then copy it into y. Since the plus is a prefix, it's the very first thing that happens. So x gets added to, turns into 6, and then copies it into y. But what if it was in the reverse order? Well, let's run it this time and make sure that it's equal to 6, like I said it would be. But change it. Put the plus after the x rather than before it. Y is equal to 5. Why doesn't it equal 6? Because plus after the variable means the increment happens after everything else. So x gets copied into y, and then it gets incremented. It's the same as writing this. Y equal. Maybe we can just do it like this. Y equals x plus semicolon. It's the same as saying y equals x plus plus. Doing it the other way, y is equal to plus x semicolon is the same as saying x plus semicolon y equals x. Do you see the difference? If the plus follows the variable, it happens after the copy, after the assignment. But if the x if the plus precedes the variable, then it's the first thing that happens, and then the copy happens. So that's why when we ran it this way, y equaled 5, because x was 5, x gets copied into y, so that means y is 5, and then 1 got added to x. So set x is equal to y, x is equal to 5, y is equal to 6. So that's the difference between a suffix and a prefix version of the increment operator. That's the increment operator. Minus is the decrement. Just means add 1 or subtract 1. If used as a prefix, it happens first. If used as a suffix, it happens after everything else. Now normally, you don't have to worry that much about it because you just put it on its own line. It's only when we're putting it in combination with other things, right? I mean, doing this, if we had done this, x plus y is equal to x, no ambiguity, right? We understand exactly what it means. So I don't necessarily feel like we need to be doing it that way very often, right? Because it makes it a little bit less clear. I'd rather separate it into 2 steps. And then there are the compound assignment operators. These are what you had in Python. Plus equals, minus equals. You didn't have plus in Python, but you got plus equals. Same thing for minus equals, times equals, divide equals, and modulus equals. So x times equals 2. X divide equals 2, right? x mod equals 2. Take the modulus, divide it by 2, and take the remainder, right? So this is the same as x equals x times 2. That's the same as x equals x divided by 2. And this is the same as x equals x modulus 2. And I guess I forgot the plus sign. X plus equals 2 is the same as x equals x plus 2. I wonder what x equals after all that rigmarole. Let's just print it out. System.out.println x equals space end quote plus x. Yeah, whatever, right? We did a whole bunch of stuff involving 2, and it wound up equaling 2. And again, professional programmers would do that rather than write it out like that. That looks just a little bit more primitive. If you have the ability to do it this way, go ahead and do it that way. So sometimes you need to convert one format to another format. What do I mean by that? What if we were doing this math here, and we needed to do a little bit of division, but we needed to make sure that it was done as a floating point math rather than integer math. Double D is equal to double parentheses x in parentheses divided by 2. What this is saying is take, oh, I did the syntax wrong. I'm so sorry. I did that in Python. These parentheses, or C++, parentheses, double end parentheses, take those parentheses out, divided by 2. What that does is it turns x into a floating point so that it'll support, floating point math. So if we do x equals 1 here, and then we calculate d like that, then d is going to equal 0.5, because 1 divided by 2 is 0.5. If we took the word double out, it would just equal 0. Let's print that one out. System.out.printf, parentheses, quote, d equals %.2f \n, end quote, comma, d, semicolon. And d equals 0.5, but what happens if you take this part off? Remove that part. Cut it out. And then when you run it, it says that d is equal to 0. The reason being is that x is an int, 2 is an int, and so it divides an int by an int and rounds down. And 1 divided by 2 rounded down is 0. But we can fix that by converting one of them to a floating point, like that. That's called casting. Casting is taking one numeric format and putting it into another. This takes x and casts it to be a double. So d equals parentheses double in parentheses x, cast x to a double. That's what it means. X is now equal to, the double version, 1.0 rather than 1. You can also cast things to an int. You can cast things to a lot of different types. So what if we have another int, like j, and we want to store d into it? That's a syntax error. Why? Because d is a double. It's a floating point type. So that's just a flat-out syntax error. But we can make it work. Int j equals parentheses int in parentheses d, semicolon. What that says is, why did it count that as a syntax error? Because it's a float and won't fit. It doesn't have enough bits for it. It's got a decimal point that's going to be lost. The compiler is saying, no, you can't do that. When we put this here, we're telling the compiler, oh, yes, you can. We take responsibility for it. We know what we're doing. It's okay for you to lose a decimal point and to squeeze it into fewer bits. And so it gets converted into an int and stored here. So if d is equal to 0.5, after it's converted into an int, it's just going to be 0. Cast d to an int. So if you ever need to cast more than just a single variable, then you need to make sure you have parentheses around everything that's supposed to get cast. If you're supposed to calculate that and then turn it into an int, you better do that. Because if you do this, if you take the parentheses out, this is the only part that gets cast. That gets turned into an int, and then some subtraction happens later. So character type, char. A character variable holds a single character, and so it's stored in single quotes, like this. Char ch is equal to single quote a in single quote, semicolon. Well, let's print out a, but behind the scenes, everything is a number, right? So we can find out what the numeric value of that is as well. X equals parentheses int in parentheses ch. Convert a to a number. And let's print them both out. System.out.printf, parentheses, quote, ch equals %c for character, comma, x equals %d for integer, \n. End quote, and we need to fill in the placeholders. So ch after the first comma, and x after the second. And what it's going to tell us is that the character is an A, and then for some reason it's going to print out 65. Right there, 65. Why in the world is it 65? Well, it has to equal something, right? Letters have to be converted into some sort of numbers in order to be held into the computer's memory and written to disk and stuff like that. And so there's something called ASCII. The ASCII value of quote A quote is 65. The ASCII value of B is 66. The ASCII value of C is 67, and so on. We can find a table pretty easily that shows us all of those. It's just called the ASCII table. So if I Google up ASCII table, or if I just type ASCIItable.com, it shows us a capital A, and then people just decided upon this in the 60s. They made this up so that, computers could agree with what numbers equaled what letters. An A is a 65, a B is a 66, a C is a 67, and so on. So if you were going to write the word feed out in memory, feed is equal to a 70, 69, 69, 68 for FEED. Did we talk about hexadecimal when we were doing our lectures about bits and bytes? Do we know what a 4A means, and a 4D, and a 4C, and stuff like that? Is that sounding unfamiliar, or?
Sounds familiar, but we just did all this in another class.
Yeah. I'm getting my brain wiped as to whether we did that or not. What are our notes from? I didn't keep the notes. Oh, okay, so lecture F. Our bitmobile and all that. That's not Java, though. Even the notes are going in the wrong folder. But we have talked about this, have we not? Have we talked about if you have 1011 and you wanted to convert that into decimal, then that's an 8 and a 2 and a 1. Is that right?
Yes.
Okay, we have talked about that. Okay. So veering a little bit from what we're talking about now, we're going to hit that topic just a little bit more. If you have those values, then that's equal to a 0, that's equal to a 1, and so on down the line, which bear with me, all right, so I'm continuing to count in binary. I counted from 0 to 7 here, and then I went to this column. I'm keeping going on. What's next after 1010? I'm going to just add 1 to it. What does it become?
1011.
Yep, 1011. And what's next?
1100.
Yep. And so if we keep adding the numbers, that's an 8, right? Because 8 and no 4s and 2s and no 1s. This is a 9 because it's got an 8. No 4s or 2s, but it's got a 1. You know, and we don't have to keep adding them up when we can just count in sequence. Oh, come on. So there we go. But what if you wanted a counting system, or you wanted to represent this data so that every 4-bit sequence was represented by a single space of data rather than 2? Because right now, if we wanted to write what the value of 11110110 was, we'd have to say, well, a 1111 is a 15, and then an 0110 is a 6. Well, that's kind of lame. Yeah, am I going to put a 0 here to indicate? Anyways, it's taking 2 numbers, 2 spots to hold every 4 bytes, every 4 bits. And that's because the counting system stopped at 9. Decimal, base 10, stops at 9. But we can use something called hexadecimal, which not only has the digits 0 through 9, but enough to get it up to 15. Needs extra digits. 10, 11, 12, 13, 14, 15. It needs extra 6 digits. That's what the hex means. And so what did they choose? They chose the letters A, B, C, D, E, and F. If hexadecimal had been invented in Russia, we would all know the Russian, letters A through F rather than ours. So in hexadecimal, that's an A, that's a B, that's a C, that's a D, that's an E, and that's an F. So if you were going to represent 1111, 0110, well, 1111 is an F, and an 0110 is a 6. So if we had a series of numbers like this, I'm putting spaces in it just to make it easy to read. Let's turn those into hexadecimal numbers, and we'll just use this chart. So what is an 0100? Just doing a straight lookup in hexadecimal, which is that column, it is a, that's a 4, and what's the next one? So it's a C, and what about that one? It's a 7, and what about that one? That's an E. How about those ones? That's an F. How about 0001? Just a 1, right? And what is a 1010? Well, you know, it's also a 10, so it's an A. And then lastly, all zeros is a 0. So what does that really mean? If we had these numbers, well, let's make them smaller though, because I don't want to have to add that up in my head. Say we had the number 1A09 in hexadecimal, and we want to convert that to base 10. Well, do you remember our powers of 1 or 2s and powers of 10s and stuff like that? Well, this is 16 to the, oh, come on. 16 to the power, where's the caret key, of 0 is the last digit. Then the next one is 16 to the power of 1. And then the next place is 16 to the power of 2. And the next place is 16 to the power of 3. So if we have the 1A09, that means 1 times 16 to the power of 3 plus A, and what did we say that an A was? It's a 10. So 10 times 16 to the power of 2 plus, how many powers of 1 do we have? We don't have any, right? It's 0. 0 times 16 to the power of 1 plus, and what's the last place? 9. 9 times 16 to the power of what? Did I hear it? 0. Yeah. Okay, so there we go. And we just have to figure it out. Now I don't quite remember 16 to the power of 3. I think it's 4096 or something. 16 power of 3 is, yeah, 4096. Oh, anyway, so that's 1 times 4096 plus 16 to the power of 2 is 256, so that's 2560 plus there's nothing there plus whatever 9 times 16 is. I can't do that in my head. I ought to be able to. It's 144. Make sure of that. 9 times 16, 144. And if we added all that together, we'd get our answer. Now I'm not going to ask you to do that. How come I didn't copy it? Try that again. All right, 6,800. So this number, this sequence in hexadecimal is equal to 6,800 in base 10. So when we're back at that ASCII-table.com page, we'll see that a capital A can also be represented by a 41, because 41 hexadecimal is equal to 65. We could prove that to ourselves. And a capital M in decimal is a 77. It's a 4D in hexadecimal. So just for funsies, if you have Notepad open, if you're taking notes in Notepad, go ahead and save your document. I think this is Lecture H. And then go to a site, the following website. Go to something called hex, H-E-X-E-D .it, hexedit, hexed.it. and go and click the open file thing and go and find your notes file. So I'm going to click open file. I'm going to go into my correct directory where my notes are. And there we see all of my notes. And we see the hexadecimal values of the ASCII values. So if I ever saw a capital A over here, I should see what this thing said a capital A was supposed to be, a 41. So back over here on our hex page, a lowercase d and a 64. If I go in here and look, a lowercase d is in fact a 64, but what if I changed it? What if I didn't like that being a lowercase d? What if I wanted it to be an uppercase d? I could come over here and I could change it to a 44. So if I come back over here and I change that 64 to a 44, watch what happens to the stuff in this column. Now it's a capital D. We have changed the ASCII value of that letter from lowercase to uppercase. We could do the same thing for the O. Now the pattern is that if it's a 6 something, if you change it to a 4 something, it makes it uppercase. So if I change that to a 4F, it makes it capital. And a 7.5, if I subtract 20 from it, it becomes 55. See, I'm making all these letters uppercase just by changing their ASCII values. I'm editing the hexadecimal ASCII values, and that's why it's called hexed.it. And if I save this document back out with export, I'm going to just call it Lecture 4HB. Then when I go and look at it, there. They were lowercase, now they're uppercase. So that's what ASCII is. ASCII is just a series of agreed upon values so that the bytes in memory can be treated as words, as, you know, language. So if we were to write out the word dad, D-A-D, then somewhere stored in memory would be the hexadecimal values 44, 41, and 44. If I go to hexadecimal and I do new file, and I type in 44, 41, 44, spelling out dad. If I make this a 61 rather than a 41, then that makes it a lowercase a. And if I make that a 64 rather than a 44, it makes it a lowercase d. So when we had character is equal to uppercase A, and then we printed it out, and it printed it out as a hexadecimal, as the integer version of it, it printed 65, because here capital A is a 65. What if we wanted to print it as hexadecimal though? You see that %d there? That says printed as an integer in base 10. But if you make that %x right there, it'll print it out in hexadecimal. You don't normally need to do that. But there, see, 41, just like in the ASCII chart. Let's make a little for loop that'll print all the values from A to Z. Now I don't even remember what a Z is on the ASCII chart. It's a, well heck, I guess we don't have to limit ourselves. We could start off at 32 and go all the way to 95. So we're going to write a little loop that does that. Int C for counter equals 32, semicolon. While while parentheses, C is less, what did I say I was going to go up to? 95. While C less than or equal to 95, in parentheses, system.out.printf, parentheses quote, ch equals %c, or how about just %c space %x. \n, end quote, comma. We're going to print out this as a character, so we need to convert it to a character. So we're going to use casting. So parentheses char in parentheses c. And this one is an integer. We don't need to do any conversion because c started off as an integer, so it's just fine to put c there. And then in parentheses, in semicolon, and we need to add one to c, so c++. Let's print it out 3 times. Let's print it out by its hexadecimal value and its normal decimal value. So I'm going to change this to %c space %x space %d. And then for the placeholders, comma, parentheses, char in parentheses c, comma, c, comma, c. Fill in all 3 placeholders. And if we scroll up, here's what we see. A space, an exclamation mark, a quote, a capital A is a 65, like I've been saying, capital D is a 68, and then the middle column are the hexadecimal values. So every character is a single byte, because a byte is 8 bits. And so down here, we were doing this. That's 8 bits. It's big enough to hold 2 hexadecimal digits. Another 8 bits, 2 more hexadecimal digits. Another 8 bits, 2 more hexadecimal digits, and another 8 bits. So how many bytes is this? This is 1 byte, 2 bytes, 3 bytes, 4 bytes. 4 bytes can be represented by 8 hexadecimal digits. There's 2 hexadecimal digits per byte. So every character is 2 hexadecimal digits, just like we were seeing on here, right? Hexadecimal 3C, that's 1 byte. If it was 3C, 3C, it'd be 2 bytes or whatever, because each one of these hexadecimal digits is representative of 4 bits. That's a tongue twister. My mouth is getting confused. So escape sequences. What about /n? /n, what is /n? If we print out a /n, it goes to the next line. We've been using that in our code, like right there, to go to the next line. /n has an ASCII value. If we wanted to look it up on ASCIItable.com, we would see that a /n is a new line, which is right there. It's an ASCII value of D, or 13. So \n goes to the next line. But there are other escape sequences as well. Why are they called escape sequences? Because if you type this in, if you type in, system.out.println parentheses quote, hello \t my \n friend double quote, and then followed by another double quote, parentheses, semicolon. What is that going to print out? It's going to print out hello, and then the \t is going to cause a tab, just like hitting the tab key. And then it's going to print my, and then it's going to go to the next line, because \n means new line. And then it's going to print out friend, and this one, this weird one, \double quote, just prints out a double quote. So when I run it, that's what we're going to see on the bottom few lines of output. It is hello, my friend. Why in the world would you need a special symbol that just prints out a quote? Because how could you do this? How could you say string name equals quote, my name is quote, Slim Shady, end quote, semicolon? Well, that doesn't work. we're getting out all sorts of syntax errors and stuff. It's all underlined. And the reason why is because this double quote is being treated as the end of the string. So we have to turn it into an escape sequence. Why is it called an escape sequence? Because as it's processing it left or right, once it hits a backslash, it goes, oh, I better switch modes. It's escaping from its old mode into a new mode. So if we change that double quote to a backslash double quote, and then do the same thing for the one after the Y, backslash double quote, now we can print that out. System.out.println parentheses name in parentheses semicolon. And so it does print out my name is Slim Shady. And each one of these things was just converted into a double quote. If you want, you can use backslash apostrophe to print out single quotes. I'm going to change them back to double quotes. So, what we have, backslash n is a new line, backslash t, tabs, backslash double quote prints a double quote, backslash single quote prints a single quote. Well, how in the world would you print a backslash if you didn't have the ability, right? What if you wanted to do this? String space file equals quote c colon backslash new backslash temp dot txt in parentheses end quote in semicolon, and then you try to print that out. System.out.println parentheses file in parentheses. It's not going to print what we want. Why? Because that's going to be treated as a new line, and that's going to be treated as a tab. So it did not print out c colon backslash new temp.txt. Instead it printed all that, which is not what we wanted. But if we put a backslash in front of these backslashes, like that, then it'll work. C colon backslash new backslash. So this is an escape sequence. That means backslash. Without it, you wouldn't be able to print anything that had a backslash in it out. It'd be treated as an escape sequence. So it hits the backslash, it goes, oh, I'm going into escape sequence mode, and it finds the other backslash and it says, oh, just kidding, let's just print it out as a backslash. But when it's printing out this one, it hits the backslash, it goes, okay, I'm in the other mode, aha, I'm supposed to print a double quote. Or, oops, I'm going into the other mode and I'm going to print a tab. And I'm going into the other mode and I'm going to print a new line. All right, we're going to stop there. All right, so overhaul chapter 3. What we're going to do is we're going to ask the user for the value of y and for the value of another int. I don't know why it says y and y here, so why don't we change them to x and y. We're going to add y to x and store into x using plus equals. So that means that operation is going to be x plus equals y. And then you're going to print that y was added to x and display the new value of x. Then you're going to keep going, multiply x by y using star equals. So x star equals y, and then print the new value. And then divide. Well, after you've multiplied, when you divided it ought to be back to kind of what it was before. And then you're going to subtract x minus equals y. Then you're going to add 1 to it, so you're just going to use x plus plus. And you're going to subtract 1 from it using x minus minus. And it says, to my eyes, it looks as if the initial value of x and the final value of x will be the same. I think that's going to be the case, because we're going to add x and y, we're going to multiply, we're going to divide to get back to where we were, we're going to subtract, it'll be back to its original value, we're going to add 1 to it, and we're going to subtract 1 to it. So after all that rigmarole, unless there's something strange going on, then we ought to wind up back with our original values. Now if you type in 0 for y, it's going to crash because it's going to be trying to divide by 0, and that doesn't work. So this is going to be x plus equals y. This is going to be x times equals y, x divide equals y, x minus equals y, and so on. Does that make sense? Okay. Let me just say, example, x plus equals y, like that. Save this and re-upload it.